Hi everyone, I'm pretty happy to be there. I will try to make all the thing from the bash and make you some demo about all this kind of thing works, so I hope it will be working. This is me. This is me. For those who don't know me, my name is Quentin Adam. I have a very unpronounceable Twitter handle. And you can find me everywhere. This is my day-to-day work. I'm running a company called Clever Cloud, and this is an IT automation company. So basically what we do is we're keeping our customers' app online. Basically people just push their code on top of Clever Cloud. We deploy it, and we make it run. So basically if the application fails, we relaunch it. If they need more scalability, we give more space. If it's not using all the possibility, we resize down the system, we make the whole no downtime redeployed system, security updates, all this kind of stuff, and people just write codes and work, which is a pretty interesting stuff. And we learn a lot because we have customers in more than 1,500 cities in the world, so big customers like French Army or a bank or things like that, and very small customers paying for just 4 or 5 euros per month. So basically it's a very kind difference. There is one of our customers, it's in Kathmandu. It's a dream for me to have a customer in Kathmandu. And we learn a lot running all this stuff, and we try to give back to the community what we learn managing the support for all this kind of stuff. I have stickers about Clever Cloud and all the funny things from myself, just as at the end. So, okay, why we will speak about virtualization, container, and other technology, and basically why do we have invented it, and why do we use it, and why it's existing. At the beginning, we have like very large computer, like basically all this room full of cables and electronics and stuff like that, and it was very large computer able to run only one software. And at the beginning, the software was running on a paper card, you know, with some hole inside the card, and the software was running. And then many software were run on the same hardware because the hardware became more and more powerful. So we were able to make the software run inside a single hardware. And working on that, we lead to the operating system to be able to manage the hardware capacity to many processes and not failing. Okay? Then we think a lot about the process scheduling. Did you remember like a few years ago the large debate between initd and systemd and all this kind of stuff? All this kind of stuff is about process scheduling and how we manage to have many processes inside the single hardware to be up and running and managing the process lifecycle. And Unix have made a lot of things on that. There is a whole Unix philosophy about all is file, a process start, a process end. You have to give back a return code about how it's made. You can make system calls inside the process, and Unix gave a lot of information and insight about how it's working since the 70s. And we lead to more and more complex application, leading to complex spaghetti OS management, because it was complicated to have all the application running on the same OS. So everyone was frightening and things like that. Then we're starting to find a way to unlink the hardware capacities from the software. So basically, we think, okay, we have a big calculator, and maybe we can split between the hardware and the software, and it can be interesting. So, process. Process is important because all about what we will speak about is a process inside Linux. Isolation of process is the ultimate goal of all this kind of stuff. The isolation is made of 3 components. First component is the software dependencies, because if you run a software, maybe you have some library dependencies, and maybe another software in your OS have not the same dependencies. So basically you have a problem and you need to have differences. The other point is the security. You don't want, yeah, I think it hurt. Sorry, LinkedIn. So, the other point is the security, because you don't want one process can act on another process if it's interact with users, especially if you are exposing in the network a service for users like web page. And if a web application can interact with another process in the OS without to be allowed to do it, we will have a problem. And the last point is the hardware resource access, because if you have an application managing what you will hit this afternoon, and another application managing what you will make of money in like trade market, you don't want that the application about the food will get all the hardware resources from the application of trading market, because you will lose a lot of money. So basically, hardware isolation is very, very, very important. Isolation is made of the three things, but at the beginning, people try to start a way to find a way to isolate things. The first interactive things was made on Linux in the early 80s, late 70s, and they called Shrutes for changing root file system. It's what it means. If you are in Linux, everything is in file. So basically, if the root file system change, you have changed the file system, and you're happy. Okay, let's try to make an isolation catch like that way. Oh, why? Is it readable that way? Okay. Okay, perfect. Just to be clear, I'm using a text preprocessor, so there is no magic. I'm just writing just few tricks to be just more easily on this. But if you doesn't get what I am doing, just cry, and I will explain. Okay? Now, text preprocessor is something pretty cool. Mine on OS X is called hatext. And for example, if I write just CCL, okay, it's writing Clever Cloud. Well, not so impressive. But when you have to write your email address all the time, it's pretty cool. Or if people asking for your biography all the time, you have preprocessor text is so awesome. So basically, picking of a container process, we are in a system, and in the system, I have write a special script in Node, which is designed to be fail, and there is a security issue inside it, so I can execute what I want using this script. So I launch a server with this script, okay, and it's listening, okay. If I want to execute something, I say, okay, I will use date, and what you say is this is writing from the logs of the servers. I have execute date. So basically, we have a problem because I can do something like okay, and if I have a look on what is on TMP, okay, there is a problem. I can handle things on the system. More impactful. If you are losing at this, there is another server there. And what I can do is change the code of the servers, so it will change the way things are running. And for example, I can steal password of the users of a server which doesn't know I am existing. So we have a problem on that. So how is it working? We can change root. How is it working to change root? I have made a place on base, and we create some of the link. If you are looking at this, okay, you have several links there it's just file, it's just directory, so I can mount and bind to the system. So I just switch root because root deserve to be roots, and I do not remember what I have done. Is something called, oh yeah, root bind. Okay. So I am binding all the stuff to be able to use it from the thing. So if you look at this, it seems perfectly normal. But if you are looking at what is going on the mount, there is plenty of stuff, and there is the way we can see I have mounted the thing. So no Shrutes. So no, if I'm using slash, I see I am inside the container, inside the root file system, and I cannot act on this. So if I'm using no problem. What is binding? I have should not start. Okay. So if I'm launching the server inside this, what's going around is there is a server running. If I'm looking at the process inside the machine, I see the TTY is really inside base, and if I'm trying to touch inside the system, I can't, because the system is no more there. I'm jailed inside the Shrute. So the root file system I've changed, and I have isolated this process from others. Is it clear for everyone? The problem with this is if I decide to say, okay, for example, I will Shrute myself inside space. So basically, I'm inside the Shrute process. I can unjail myself just using a new Shrute inside the root file system, and then I'm in the top of the level of the system. So basically, it's not very safe. If we're thinking about this, one, if it's have a very weird relationship with root, it's very easy to break out of a Shruting system if you have several access. But more important, it may allow you to have some privileged escalation. Just thinking about that. If you are inside a file system, you're Shruting inside another file system, then all the new system you're using is the new binaries you put there. So you have a big problem on that, because if you successfully introduce a corrupted binaries inside it, you can pop up to the root level of the system, because you are not managing it quite sufficiently security. Okay, so it can introduce new leaks in the system. It's allowed to manually manage library dependencies, and there is no hardware resource management, so it's not cool enough. This is why people starting to think about jails and containers. What is jails and containers? This is the name of system you have heard about, like vServer, OpenVServer, LXC, and now you have Docker, runc, Rocket, and whole the family. Basically, the runtime is always the same. When you're running a Docker container, you're not using Docker, you're using the Linux kernel. So basically, you don't care about the performances and things like that, because all is based on the Linux kernel and particular feature on the Linux kernel. So basically, between LXC and Docker and Rocket, it's almost the same thing. It's just like how it's coming to your shell will change. It's the paint around that. First, all containers are using something called the Linux namespace. What is the Linux namespace? It's a pretty old feature coming from the 2.4 in 2002 years. It's a feature able to wrap a namespacing of thing to another to be able to just think you are in another namespacing. The first thing made in the beginning was the ability to switch the file system with the MNT like namespacing type. But we have to wait for 8 years more to have the other things able to map PIDs, a network IPC, which is IPC is the thing, the hardware. It's a hierarchy. It's the way the hardware talks to the process. The naming on the network, which is HAS, and the user mapping. So what is important with that is namespacing is just a mapping between actual system resources and virtual system resources. So basically, it's just a mapping style. And the other things to make a container is something we call the C groups. C groups is a way to quota and to secure access to the hardware resources of the machine. So C groups are not a security feature. It's only a way to control access to the actual capacity of the hardware or the hardware you put it on. So, and if you put all together, you have to understand this. A container is not something with strong barrier, is not something complicated. It's just like Linux process with a bunch of special permission, nothing more. Just make a demo around that. So I'm connecting to the Docker machine I will use for test, and the Docker machine I use for test is, so I'm on Linux, and if I have a look on what is running on top of Docker, there is 3 images running, which is Cassandra, Titan, and Elasticsearch running inside the container. And I say, okay, it's cool, but how it's running inside it, if you made a look of what is running, you can see your Java is running there. This is a Cassandra system running in root. If you're looking inside the container, you will not see that like that, because there is a namespacing mapping. But as a global system viewer, you just see all the process running inside your containers as what they are. And as Docker launch all the containers himself, all is run by what you want. So basically, this is the first problem you have. You're not running inside a safe environment. There is no barrier. There is nothing like that. Containers are just Linux process nested for each other. Okay. The problem with that is the isolation and side effects you can have. Just thinking, maybe we have a problem on this laptop, and you have a lot of containers running alongside each other, and one of the containers will make a fork bomb. This demo is a fork bomb, but I will explain. There is plenty of possible explanation for what's will happening. Okay, So I'm inside the Docker, and I'm launching a fork bomb. This is something calling a fork bomb with Ruby. It's not the point. What is important is there. If I'm trying to just SSH to the system and trying to list process, I see there is a lot of process running. Bigger? Yeah. Like we can see, there is a lot of process running, a lot of process running, a lot of process running. And the problem we will face, if I achieve to access to the whole possibility of process inside this machine, what will happen? No other container can create another process inside it. So in a few seconds, I will not be able to create a single process. So inside one of the container become growing on process or file descriptor or anything like that. And he hit it for the rest of the OS. So there, as a root on top of the OS, I have no possibility to create another process. If I just try to make a date, I can't fork because all the process layers are just taken. This is one of the problems of isolation. You are running on the same system. So basically, if you're looking at this, what's happening is there is number possibility to fail. Because, just thinking about that. We're launching a React server inside a container alongside, I don't know, 500 container inside the machine, okay? React love to have many files open. Your system is a little bit misconfigured, and you're launching, I don't know, 5 React servers in this machine, and you hit all the file descriptor opening possibilities on whole the system. Then, your simple MySQL, WordPress, and PHP container will try to just make the log rotation system, you know? Just change the file to write logs. Yeah, but it can't open a file. So we fail to do that. And you haven't the logs. But more, the file will be bigger and bigger and bigger, and fill all the disk space. And before you will understand the full story I just explained to you, it will be a lot of time. Because you're managing several things, and one thing in a place going crazy, and you cannot thinking about that. The problem is Linux processes are not isolate enough. And it's the same thing for all this kind of stuff. Because it's container are just Linux process. It's not isolation. It's not able to manage this kind of stuff. The other problem is about the Linux philosophy. Basically, Docker is a daemon. You have a Docker client, and the Docker client is speaking to the Docker daemon to start some process. So basically, the Docker daemon is managing some process. The problem is this is exactly the work of the init system, the PID1. So basically, you're running inside a system with 2 PID1 and 2 init systems fighting together. Just take the time to go on the internet and read some discussion about people from Docker and systemd fighting together about how is it working. But the point is, Docker don't want to merge application of system process management like systemd inside the container system. So basically, you're running with 2 init systems. And the problem is not only that. Inside a container with the namespacing, you are viewing as a PID1. So your Java is thinking is a PID1. Did you try once to attach something like gconsole inside a container to a PID1? jconsole don't want, because it cannot bind to a PID1. So every process has to try to be a process manager inside a container. So it can be a little bit like complicated to manage this kind of stuff, because it's not the whole way that Linux works. And I cannot speak about several other problems like monitoring. If you're running some monitoring, you need to have an access to the system to say, okay, this is the network, this is how it's going, and things like that. You cannot rely on that, because what is going, you have to mask all the things inside the container to be able to watch it from the exterior. Because if the monitoring can go in the system and say, okay, there is this kind of file descriptor open, this kind of stuff running inside the networking, this kind of stuff running inside the CPU. It cannot do that inside the container, so you have to monitor all the things from outside the container. So the monitoring, as it's existing today, is unable to do that at all, because it have to refresh all the things in the same time. How to know which is the software and the process will eat all the bandwidth in this case. So the search is not over. How we manage to have a proper isolation inside the system? Years ago, there is a guy who wrote a thing called QEMU. It's an emulation system able to think as is a processor. So basically, you have a running system, and on top of that, you have another process who think is a processor and emulate like really what's running on this. If, for example, if what you use when you're working with Dolphin, the GameCube emulator, this kind of stuff, you have something in your processor would translate and make believe there is a processor of another architecture. Okay, this is pretty slow. Then some guys invented Xen. What is Xen? The term for Xen was para-virtualization, which is this kind of word we don't know really what it means, because everybody using it for several things. But Xen was a way to patch the Linux kernel to be able, with a very minimal hypervisor OS, to launch other OS. So basically, you just start a new kernel inside yours to be able to reproduce a full operation system on top of it many times. Then a revolution comes. People from Intel release a new set of CPU instruction called VTX. It's 2003, and Intel say, okay, with VTX you can do something really interesting. You can run two software absolutely separate on top of the same hardware. So basically, it's a set of instructions able to context switch totally the hardware from an operating system to another. Okay? What is really interesting with that is you can parameterize the access to the hardware. Basically, what you can do with VT instruction will be to say, okay, I have two network cards. One will be used by this operating system, and one will be used by this operating system. And you can totally hide a part of the hardware you have from one system to another. And you have access to the different system in the same time. Okay? But the isolation between the two systems is guaranteed by the hardware and not other thing. So, how is it working? If I connect to a server running some of virtual machine, and I have a look at this, what I see is not the whole, there is no, you cannot see there the whole process running by a virtual machine. A virtual machine is a single process running called called KVM. But inside this, you don't know what is running, because after this, the context switching of the processor, the CPU, leads to a totally new OS. So you cannot, there is no interaction between the host and the virtualized system. Between is guaranteed by the CPU. And you can run a lot of things like that. I don't know how many is run inside of it. Something like yeah, we have 100 and more virtual machine and parallelized operating system inside this, but quickly made by a whole completely different system. What is mean if one of the kernel of one of the virtual machine fail, other virtual machine and the host doesn't get anything. It's okay. If one of your process inside a container go to a kernel panic, the whole host is done, because there is only one kernel, and you don't want to share the kernel between this kind of step. So now we can talk about performance. What is the problem about performances on virtual machine and things like that? What is the boundary you have? When you have a problem of performances inside your application, what is the boundaries you face? Is it the RAM? RAM is cheap. We never miss some RAM. It's okay. Is it the CPU? Did you burn the CPU sometimes? I never burn the CPU. Or is it the I/O? When you're doing an application which is basically a software exposing an application on the internet and getting some information from a database, you never be bound by your CPU. The problem you have is the I/O, access to the disk and the network. There is the very big problem of performances. As an hosting provider, we see a lot of application running. I never see a single application have a real problem on CPU. The problem is always the input-output of the whole system in the network and the hard drive. So all of this thing is working. If you're thinking about that, the I/O system is very more easy to manage with the VT instruction inside the CPU than inside a single system. So this is why, if you're looking only as a benchmark on CPU, it's not realistic point of view. You need to have a full picture of problem on performance and need to choose your fight. The other problem is around the dark magic. All the containering system are using low-level dark magic Linux thing. For example, we will speak about LPLinux. Who knows LPLinux? So, everybody say LPLinux is so cool, it's so small. How did you get so small? Nobody knows, it's not a problem. LPLinux was based on something called microkernels. Then they changed to something called muzzle. These two things are people who think the JOTB is not good enough, and they are rewriting it to be able to compete with that. The problem is if your whole software stack is running on JOTB, like MySQL, PHP, all this kind of stuff, you're running inside something you don't know what's running on the system. And the problem with the whole Docker ecosystem is we're speaking about people triggering low-level Linux feature, but never get what is really running on top of it. So if you don't know, how do you will manage it? And this is one of the problem with muzzle. The other problem is the dependencies monolith. If you're thinking about that, your application have dependencies layers. So your code will rely on the build system to be able to be built and dependent. Your libs rely on the build system and dependency management like Maven, NPM, Gradle, something like that. But are you really linked to the native library of your system? Then you will rely on containers. The problem with that is then you will introduce a non-flexibility on the dependency management. So if there is a problem on OpenSSL, you know, it's never, OpenSSL have never been failed, you know. If you're running inside your build system, you have nothing to do because you just build the application and the flexibility of the system will be able to update this. But if you're running inside a container, you have to update the container to manage the OpenSSL bridge. And you never know if there is a dependency between the kernel and a native library, for example, JOTB. A container is unable to managing the dependencies because a container only knows all the binaries except the kernel, and it have no hands on the kernel. So if you want to really manage native library, you need to manage a kernel as well, and this is a virtual machine. Maybe you need a particular access to hardware, then you will link to appliance. But each time you go down on this list, you put yourself a lot of work on your head because you have to manage more things as the spectrum grows. And you need to think about the kernel and the OS linked to the system. So if you choose a way to manage the kernel, just think about that closely. The other thing is DevOps. Everybody speaks about DevOps, but I just want to warn you about something. DevOps can be a wonderful opportunity, and you will all work in a good way. If DevOps means using developer and ops together, but if DevOps become developer making the job of ops because it's more easy, I think it's a failure. Because developers are not ops. And there is plenty of things to understand as ops. And more, if developers are making the job of ops, they have no time to making the job of developers. And I think they are more valuable at making the job of developer than the job of ops because they don't know how to say. So basically, what I want you to remember, container and virtual machine are not the same. So please never say again the thing like container are like virtual machine but lighter. I don't want to hear that because it's false and it will make you very big security issue. Never run code on containers on parallel of people who don't know each other because it's a security breach. Is exactly the same level of security of people making mod PHP all together like plain old virtualized PHP inside OVH. You know, it costs €1 per month, it's okay. But really, it's a security breach to make this run process all together alongside the same thing. And the other thing is, when you say Docker is native on OS X, it's not native on OS X. It's native using the virtualization to have a Linux kernel because there is no container on Mac OS X. Okay, so even the Docker for Mac, the new beta of Docker for Mac, is using a virtualization. It's not VirtualBox because VirtualBox is old and there is plenty of things which are not useful to run Docker. It's Xive, but it's still using a Linux kernel. So be careful about terms like native. Thank you very much for listening. I give you a coupon for Clever Cloud if you want to try. I'm Wax on Twitter. I have plenty of stickers, and if there are some questions, I'm open for questions. Thank you.
So I would like to know what is the best way to monitor inside of a container, because if we cannot access inside of it to get some information, except of the process in the host, what is the best way to monitor inside of the container?
Yeah, I'm asking the same question to myself every day.
Yeah, thank you.
The problem is, if you want to monitor something, you can monitor if the process is alive or not. Okay, it's simple to do that. But if you want to monitor things like how many operation on the disk, how many operation on the network, what is the disponibility on the drive, on hard drive, how many memorize RAM is consumed by a process and things like that, you need to have an external access. And the problem if the external access is outside the container. So it's not okay to monitor the system outside the container. So you put it inside. The problem is if you put it inside, you need to have a process manager inside the container to start your application and the monitoring process. And the problem is your monitoring process have to get the data inside the OS. But inside the container, the OS is totally fucked. So basically, to monitor properly containers, I think there is only functional monitoring, like if the process alive, yes, no, no, kill the container, start it again. It's the only way I'm trying to do that. But yeah, it's really poor as a data to understand what is the problem. You just kill the thing, reboot it, and maybe you're doing that like every 4 hours. I don't know. Do you have successfully passed some information to you or not? Yeah. Some of the people will learn something. Okay, I'm happy.